Hello everyone. Going to update you today on kind of what we're doing for the rest of the semester, and we're also going to do the lecture for color theory. So first of all, I want to say to everyone, this is not obviously ideal to have a studio class taught remotely as opposed to in person. So I'm going to be lenient and give you extra special consideration. I'm going to be patient with all of you, and I hope that you'll be patient with me as well as we move to online or remote learning as opposed to face-to-face. So today we're going to talk about color theory. Team Scarlet goes first watching this, then Team Navy. You can kind of, one plus about this is you can kind of learn at your own pace. Stop the recording if you need to, take more thorough notes, and move it. You can work ahead if you want to. You can work on the projects in any order that you want, honestly. So keep in touch, keep in contact with Ian and myself. Send us messages, text messages, email us, or do video chat. I'm going to have virtual office hours on Thursdays from 1 to 4 starting this week. That's where you can do FaceTime with me, or Google Meet, Google Hangout, or just email, phone call, text message, but throughout the week as well as things come up. So today, for this color theory lecture, make sure you take notes. This is going to be very helpful and instructional for your color project. You guys are doing the poetic color, so you have to pick a poem by one of the poets from that list that I provided. So you're going to use the color terminology today in that project and pick some of those themes out. So your notes today are going to count as attendance. So make sure you take thorough notes and then upload or scan them in to the media album so I can check your notes for attendance. So today we're talking about color. I'm going to enlarge this. And one of the things to think about for color is that it is subjective, based on your kind of understanding or even just your perception of color. One of the things is we all know we see color differently, and even some of us maybe have color deficiency or are color blind. That can affect the way you see color as well. Another thing to keep in mind or think about is that how color is light, and that we see color based on how light hits the object and our brain perceives it. So it's really phenomenology when we're talking about color and how we respond to it. It's also very personal. Some people might like a particular color. You might like blue, you might like yellow, someone else might dislike yellow. So for this first slide here, what we're thinking about is how artists have used color. This is a painting by Jan van Eyck. Same guy who did the Merode altarpiece, the Adoration of the Mystic Lamb. And what I really like about it is this sort of prismatic area right here where he's using the entire visible spectrum of colors. So he's using color as this sort of like enigmatic and mysterious and special significance because it's here in the angel Gabriel's wings as they are talking to the Virgin Mary and saying, "You're pregnant," right? You have this special baby inside of you. So here color is used as symbolic, and it's used as this special meaning or significance. And artists are always using color that's at their disposal. So as scientists, as artists find out more about color, the artist's work then gets better or stronger because they start to have a bigger conception of how to use color. So that's what I want you to be thinking about. That's what we're going to be talking about today. One of those other things that, thinking about color is that in a way, it's not only subjective in how we see it, but also how we've named it. So we know that throughout the world, different tribes and cultures will have different names for colors. But not only that, but some cultures won't even have the same name or a name at all for a particular color. For instance, during the medieval era, during the ancient Greek era, they described the sea as being wine colored, which is really interesting because if you think about wine, it's either really, really pale or sort of a reddish purple color, where we would describe the sea as being blue, right? Or in Japanese culture, historically, there wasn't a different word for green or for blue. Right? That green was thought of as being nature, but there wasn't a distinction between the color blue or the color green. I'm showing you this image by Millet because it's really interesting. You have a blind girl, and as a young mother, she has her young daughter, and how is she going to be able to explain color, right, to her child? And a lot of our observations about color, whether it's Crayola, thinking about crayons, or when we're young and we point at something, a lot of times we're asking parental figures, our moms or dads or older siblings, what color is that, right? And that's where we start to get more specific, perhaps instead of saying just like blue, maybe it becomes aqua or teal, or it becomes robin's egg blue, for instance. So we can get much more specific with that. So I want you to be thinking about color and how it's perceived, but also how you name it and how you associate with it. Color perception as well. The Impressionist artists were really interested in light and how that affected color. This is the same scene painted 2 different times by Claude Monet. So on the left here, we see perhaps like early day, and you have bright sunlight and contrast hitting this building, right? And it's very bright and luminous. And then on the right, it's a little bit more subdued. So this is the Rouen Cathedral later on, maybe closer to dusk, later in the evening, and there's reds and blues and purples. Same scene. The building's the same color, which we describe as a local color. But here, throughout the day, those colors can seem to change or shift, right? So one of the ways that we see color is based on this phenomenon that Sir Isaac Newton had discovered. That is that the entire visible spectrum, right? If you think about his experiments, taking a prism, having white light go through it, and it refracts into this visible spectrum. Roy G. Biv, right? Did anyone memorize the colors that way? Roy G. Biv. It stands for red, orange, yellow, green, blue, indigo, which is kind of wishy-washy, and violet. At the time, Newton thought that 7 was the sort of harmonious number based on the same kind of like tones that are represented in music. And so he kind of at a stretch created this concept of indigo, which some people describe as being denim blue color, and some people describe it as being purple. But if you look at this, there isn't that much difference between what we call indigo and what we call violet. And then look at green, for instance. Green goes all the way from yellow all the way into blue here. We would describe all of these colors as green. So this is the visible spectrum. Also interesting to note that these all have a certain electromagnetic wave to them, or frequency, shorter on one side and longer on the other. This is what humans can actually see. So there's a broader spectrum of wavelengths, but these are the ones that we can actually see. Some animals have a more narrow spectrum, and some animals have a wider spectrum. So it's kind of curious to think about, like, these are the colors that we know. What colors objectively might those other wavelengths be? We can't see them, we can't perceive them, but they're still there. This is the color that we can physically perceive and our mind can interpret, right? And so if you're thinking about what's happening here, is your eye is essentially like a camera, and we have at the front the lens, which is like a camera lens. That's your pupil, right? That's where light enters in. And then at the back here, we have rods and cones. And this is where your brain gets the information. These are like little sensors that tells you what a color is. So you have the object, you have light hitting it, and then it bounces back, and whatever wavelength is not being absorbed by that object, say an apple for instance, your eye is perceiving it as red because the molecular structure of that apple is receiving all light right? And then it gets, the red gets absorbed. All the other colors are bouncing back to your eye, right? So, and so here we see the rods and the cones in the back. And I think when I explain that apple, and I think I may have explained it a little bit backwards, the red is what's not being absorbed, right? All the light is being absorbed except for red, it's bouncing back. So that means if something's truly black, it's absorbing all of those wavelengths, right? And if it's white, all of them are bouncing back, so all of the color is present. So I want you to stare at your screen, right? Stare at the screen, at this dot. We're gonna mess around with our perception here. So we see this image by Jasper Johns. Stare at this white dot for 15 seconds, and I'm just gonna be silent when you do this. And at the end of this 15 seconds, what you're gonna do is you're gonna shift your attention from that white dot to somewhere in the room that's white. And I want you to see what happens, okay? So I'm gonna count to 15 in my head, and at the end of the 15, we'll see what you see. Whoa, trippy. It worked. It worked for me. Like I'm getting this like after image. It's this kind of vivid image that is being produced on this white wall. What do you see? An American flag, right? The correct colors. What's happening? What's going on here? Well, what's happening is those rods and those cones in the back of our head are being, or the back of our eye are being saturated with that intense color. And it gets, for whatever reason, its signals crossed, and to compensate for that, it throws up, well, it reveals, doesn't throw up, but it reveals the opposite color to sort of compensate for those rods and cones being saturated. And it's very specific color. So this kind of looks orange, right? And if you think about a color wheel, blue is directly opposite the orange. So we see the blue. What's opposite green? Well, red. And what's opposite black? White. So we have this effect of contrast and colors, complementary contrasting colors, getting reversed in our mind as our rods and cones get saturated with this image. So it's a really interesting optical illusion that works on the idea of after image and color saturation. What's happening here? Well, I want to ask you this question. What color are the strawberries? Do they look red? Are they red strawberries? They're actually not. These are actually all green. And you can see on the left here, this is the colors that's actually in this image. And then over here is the way that your brain is processing it. It's called color constancy, right? You think of an object like strawberries as being red, so your brain wants to see red there, even though this is green and gray. Trust me, I know it looks weird, but what's happening if you cover this side of the screen is the red is really an illusion that your brain is trying to help develop the image for you in your brain. Do you guys remember that blue, black, white, gold dress a couple of years ago? Well, this is happening on the same principle, color constancy, right? And it's kind of a phenomenology thing. How about this cube? Do you see this cube here? What color, and answer me out loud, okay? I know this is weird. You're watching this video online, you're by yourself, but I want you to answer so that you can dedicate it to a particular answer. What color do you see here? Okay. What color do you see here? Perhaps you said orange here, and perhaps you said brown here. Actually, these two colors are the exact same, and here we see this teased out or explained on Photoshop, because I know I'm messing with your brain, right? It's crazy. It's hard to see these two as the same, but what's happening here is because this is surrounded by such dark colors, it's making this look lighter and brighter and more orange than it actually is. And here, surrounded by lighter, brighter colors, that makes it look more subdued. And actually the right color is kind of in between. It's sort of this caramely orange color, and you can see, boom, this is all the same color here. But what the artist is able to do is use something called color subtraction and simultaneous contrast. And a bit of this is proven here as well. These are the same oranges, but when we compare this orange to mostly green, it doesn't look as dark. It looks a little bit more bright, especially if you squint at this. And then on the right, it looks a little bit darker because here we're comparing it mostly to white. So things appear darker on a white background than they do on a dark background. So this is called color interaction. And this was developed by an artist named Joseph Albers. And this is pretty cool because Joseph Albers was a professor at the Bauhaus School in Germany in the early 20th century. The school was actually shut down by Adolf Hitler, and Joseph Albers and other artists emigrated to the United States. Joseph Albers was very influential in terms of how 2D design and how color and composition are all taught in the United States. He first taught at a college called Black Mountain in Asheville, North Carolina, that no longer exists. Then he moved to Yale, and he developed this series of studies called color interaction, and how to think about color and how to study color as an artist, how to really think and identify individual ideas, and that sometimes seem subjective but can become more objective. And what's cool is at Yale, when he developed this book and this process called Interaction of Color, he taught one of my professors, Bill Itter, and then I learned from him a lot of these techniques that I teach in this class, 2D design. So in a way, I feel like I'm kind of like, the child of Joseph Albers and his teachings, and so in a way, it kind of makes you like the great grandchildren or the grandchildren of Joseph Albers. So there's a neat kind of lineage or connection there. If you look at this image, this is the same idea of color interaction, but just shown a little bit more intensely. This color right here, how would you describe this color? Sort of looks bluish, right? And you got this blue here, and you got this kind of bluish here. How about here? What does this color look like? Maybe pinkish, right? Or a rose color, and you kind of see this here. It looks more like red. But guess what? It's the exact same color. But because of color interaction and color subtraction and these contrasts, it looks more blue over here because of the red, and here it looks more red because of the green surrounding it. So this is really powerful information that you can use as an artist to be able to use one color but make it look two completely different colors in different contexts, right? And Molly knows a lot about this because Molly was in my color class, and we did some more of these kind of color studies and learned about how we can shift color this way. There are two sets of color systems. One is additive light, and the other one is subtractive. So those of you that have done theater design, you know that theater lights are not the typical red, blue, and yellow. They're actually these colors here, red, blue, and green. And when you overlap those, it's kind of weird to think, but if you overlap the red and the green, these lenses or these gels, right? Haven and Travis know what I'm talking about because they do some theater lighting, right? When you overlap the red and the green, it creates a yellow light. And when you overlap all of these gels, it creates a white light. Because think about the light has all the colors in it. So when you're adding those gels back, it goes back to white light. Versus subtractive color system is what you're using in this class, like painting and printmaking. Anything that's printed, like posters, that uses what's called CMYK. So cyan, magenta, yellow, and black. And if you mix the blue and the magenta, you get this purple. Sometimes people think about a primary set like red, blue, and yellow, and someone said, well, you can't, why are those the primaries? And they say, well, you can't mix red or blue or yellow. It's true to a certain degree, but you can actually mix red. And for those of you who take advanced painting, you can have magenta, this really nice quinacridone magenta. You can add yellow to it and you'll get red. And it makes this really beautiful red. But here we see as we add the colors back together, they go more towards black. So it's considered subtractive. Color wheel, thinking about color wheels throughout history, different artists had a different understanding of what color was and how to mix it. They've had different primaries throughout. So the art paints that Da Vinci or Michelangelo used, they actually considered green a primary. They had a different set of primaries. This is Goethe's color wheel in the early 19th century. This is an artist, a French chemist, Chevreul. This is his color wheel. And this is the more kind of traditional universal color wheel that we use today. It was developed by Johann Itten, who was another one of those teachers at the Bauhaus who really did a lot, just like Albers did, to make color understanding and learning, a little bit more universal and easy to understand. So we have a 12-step color wheel. And what we can do is we can start to make some comparisons or some relationships between colors. The first ones are really obvious. Those are complementary contrasting pairs. That is any color that is its opposite corresponding pair, like red and green, orange and blue, yellow and violet. What's interesting about this, and this is what these triangles here are pointing to, the primaries and the secondaries. What's interesting about this relationship between a color and its complementary contrasting pair is that all three primaries are present. So if you think about yellow, for instance, which of the two other primaries are missing? Red and blue. Well, they're present in that next color, right? They're present in the purples. You have red and blue. So in this also, if we look at this, we have yellow here, we have blue here. Well, what's in between it? It points to our secondaries. So primary colors first are the red, blue, and yellow. If you're defining them out, primaries are your kind of building blocks for mixing other colors from. Secondary colors are those colors that are pointing to the in-between. So you take yellow and you take red and you get orange. Here we get purple from red and blue. Here we get green from blue and yellow. The third set are called intermediates. Those are the colors that are in between, like for instance, between yellow and orange, we have a yellowish orange, and we have more of a reddish orange here. So breaking it into more specific submixtures. So if this one's 50% yellow and 50% red for this orange, this one will be more like 75% yellow, 25% orange, and just kind of varying the distribution of those colors. So that's primary, secondary, and intermediate. Tertiary colors are when you mix the color and its opposing color. So say mixing yellow and violet would give you a tertiary color. These tend to be chromatic grays. So one of the collages that I want you to do is to, each one you're going to do a storyboard first of pick a poem that you really like, that really represents your personality or you relate to it, you think it has some visual imagery in it. And then you're going to do sketches, how you would interpret that poem into, say, breaking it into 4 sections. And then you're going to make a drawing for each of those 4 sections. And then when you have that, you're going to make a collage. For one of those, I want you to be thinking about color harmony and different mixtures. So you'll through each of these, you can choose a structure, a color structure for each one of those collages. So one of those might be a primary color scheme, which would be using red, blue, and yellow, for instance. Another one that you could pick is, say, warm and cool contrast. So you could have most of it oranges and reds and yellows, or the rest of the collage contrasting and have blues and purples and greens. So you could do warm and cool contrast, or you could simply have like mostly yellow and mostly green and call that your warm, cool contrast. Okay, so warm colors are colors that have the phenomenon of half of the color wheel sort of looks hot or warm because of the idea of like fire, and the other half looks cool. So like yellow and orange and red look warm. Green can be a little bit more either, because you could have a yellowish green that looks a little more warm, or you could have a green that looks more blue and it looks more cool. But the reason these colors appear or perceived are as cool is because ideas of like water, the sky, they tend to be cool, so these colors feel cool, right? Versus warmer colors like the desert, sand, fire tend to be warm, right? Go to any bathroom in any country, and whether you can read the native language or not, you're going to know which of the faucets, which of the handles is hot and which one's cold, because it's going to be red or blue, right? That's warm and cool. So here is an image here that is using mostly warm colors, right? There are some greens, but even those greens are pretty warm. So this is a warm scene. And it's also using what we call local color. Local color is the actual or objective color of things the way that we perceive them. So for one of your collages, they could be using local color. One of them could be subjective color. I don't know why this got X'd out, but this was meant to show you an image of Andy Warhol and different colors. Like think about the Marilyn Monroe. He would randomly assign different colors to the Marilyn Monroe, that is subjective. That's subjective color. So local or objective color, and then subjective color are when the colors do not represent the actual local color. So analogous color, one of your collages could be set up based on analogous color. That's where you use colors that are really similar or closely related. These are colors that are touching on the color wheel. So here we see on the left the Van Gogh image, which are mostly like these kind of neutral tones, yellows, oranges, and then over here these nice like really autumn or fall colors, this dress that moves down and goes from yellow to red. You could have this in blues or greens or purples, yellows, oranges, red. Basically it's like almost making your painting look monochromatic. Okay, so there's 3 different classifications for color and how to talk about color. So we're going to walk through each of these. The first one is value. You could have a color, say blue, and you could make it lighter or you could make it darker. And so when you make colors lighter, that is called tints. And here we see the blue adding different levels of white, different tints of blue. And then here we see a color like, for instance, you can see like this is the appropriate band of pure color here, and then it goes darker towards shades here. So it's kind of different because if you think about like, well, what does a shade do? A shade makes something darker, right? But what about tints? Like someone says they tint their windows, it means to darken it. That's counterintuitive. Tints in art is actually to add white. So someone should say like, oh, I got my windows shaded in my car, but they don't actually say that. They say tinted, which is a little counterintuitive. So here is an example. This is actually here, since I couldn't show you the Warhol, this is an example of arbitrary or subjective color here. It's not the actual colors of the scene, but what it does is it breaks it into different values, and if you look at this in a black and white kind of framework, it still makes sense visually. So you could have lighter or darker colors, but they kind of make sense visually. The next of these 3 classifications, so we have value. The next one is saturation. And saturation is intensity. Saturation is how light or dark something is relative to its color. So not necessarily tint or shade, but rather brightness in terms of luminosity, right? How intense something is. And Gauguin here paints something in Tahiti where the colors are nearer the equator. The sunlight has less of a sharp angle. It makes things brighter. Versus if you've ever been in the north, like in Michigan, or in Europe, if you go to like Germany or Scandinavia, the light there is different. Things look a little bit more gray, or they're less intense, they're less saturated. And there are 4 levels of saturation. There are prismatic colors. Those are colors of the rainbow. They're going to be your most intense and saturated colors. Then you're going to have muted colors where you start to add other colors to it, and it's going to bring down the saturation. Then you have chromatic grays. Those are colors that are directly opposite, mixed together on the color wheel. And then the last level of saturation are grays that are monochromatic or achromatic, like black, white, and gray. Those have no saturation to them. This is an image by Aaron Douglas, a really important African-American artist during the Harlem Renaissance, who used this idea of levels of saturation. Almost looks like transparency. Really, really cool image though, where he's combining some of these complementary contrasting pairs like yellow and violet and making them either more intense, more prismatic, or less intense and more grayed out. Color relationships. I want you to think about color relationships for your poetic color studies. Think about how you are organizing each individual collage and using the colors in it to say something about the scene that's being described in the poem or about the visual composition itself. So here's a pretty obvious one, and this is color relationships that are directly opposite the color wheel, like red and green. This is complementary contrasting pairs, and here we can see they're directly opposite the color wheel, and here is Van Gogh using that. Lots of reds, lots of greens. And it can create like a really psychologically charged image. But most of the time when we think about red and green, we think about Christmas, right? So maybe a more sophisticated complementary color scheme would be like orange and blue. And that's actually a really typical one. So here we see a complementary contrasting pair, mostly orange and blues, or this here, mostly orange and blues. That can get very predictable though if you think about orange and blue, yellow and violet, red and green. The next set of color harmony pairs is split complement, and that's going to be one of your collages as well, to do a split complementary pair. And if you look at this, there's some yellow here, and there's a sort of bluish green and reddish violet, and that's represented in this kind of split complement here, this very fleshy, really almost grotesque painting by Jenny Saville. And her paintings are intentionally crude and really, really fleshy looking. This is a very beautiful painting by Matisse that shows an aspect of split complement too. You've got the green line there, and you've got, if you see where the green is, and you got the blue and the red here, kind of have the same thing, bluish and red here. So this is set up on that split concept idea. The next color harmony pair are called color triad. If you think about your basics like red, blue, and yellow, that's a color triad. So a color triad is any three colors that are equidistant on the color wheel. So not just primaries, but also the secondary colors. So here is a primary color triad, those three colors that are equidistant. But you could also do this with the intermediate colors or the secondary colors as well. The last, and this one is a little bit less specific, because I think once you start to get into 4 or more colors, the colors start to seem a little bit more random. But a color tetrad is where you either superimpose a square that's equidistant or a rectangle to just make a relationship to 4 different colors. So we could compare these 4 colors or these 4 colors and keep spinning that to make a relationship between these colors here. The next thing we want to think about is how the color can influence the psychology of a scene. And I want you to be thinking about this with your poetic color studies. Because here Picasso is describing a scene on the beach, but he's also doing something more than that. It's not just the 3 figures. They're in a somber mood. They look depressed. And this was during Picasso's blue period. After his friend Carlos Casagemas passed away, died by suicide, Picasso went into depression, and he entered a blue period, and he made his works reflect that. So this is Picasso showing himself depressed after his friend had passed away, and he left, a young child and a mother behind, and kind of thinking about the repercussions there. So color can be used to describe a scene, but it can also be used to describe a mood. And I want you to think about that for your poetic color studies. I want you to think about setting the scene and drawing out your image, but selecting the colors to influence how the image reads, how it maybe affects the person that's viewing it. So you could have a flower, and a flower could be happy and reds and yellows, or it could be sort of somber and depressing. It could be blue and drippy. Think about how you're going to portray something and depict it to get your point across from the poem. What is the poem? Is the poem happy? Is it sad? Is it introspective? And see if you can reflect that by using your colors very intentionally and in a way that's instructional. Color can evoke mood. Color can evoke meaning and expression. The last thing that I want to leave you on before I talk a little bit more about the assignment is, remember I mentioned being colorblind? That's a thing. It's something like 1 in every 8 males have some sort of a color deficiency, whereas 1 in every 200 females have some sort of a color deficiency. That's right, men are usually not as good at seeing for whatever reason. Evolutionary science, biology has made it more important for women to be able to see very specifically. So usually, if a female says hey, dude, you don't match today, listen to her. She's usually right. But this is a color test that you can take. This one's more specific than maybe one that you've taken at your optometrist. Here is the website below, but you can also just do a Google search for it. If you look for the FM100 color test, and it's on this website by X-Rite. It's called the Farnsworth Munsell 100 color test, because we have 4 slots of 25 colors. And it's interactive, and what you can do, this is just a screenshot, but what you can do is organize these colors, like pick and drag this one closer to this kind of mustard color over here, drag this pink further over to this spectrum here, and then what should happen is a nice even gradient all the way from this kind of mustardy color to the violet color, so you can tell the difference between two colors that are really, really similar. You want a low score, and anything below 20 is pretty good. For instance, I scored a 0. Yes, that means I have perfect color vision, which is pretty fitting. I'm kind of a color guy. I love color. I explore it a lot in my work, but also in teaching color theory. My wife, she's got pretty good color vision. I think hers was like a 9 or something. So we argue about color a lot. It's probably like the only thing we actually argue about. Either that or something that like we can Google, like, was Brad Pitt in this movie or not, right? Silly little things like that. But so like when we argue about color, it means I'm usually right? That's one case. My wife's right 90% of the time. This is that rare 10% where I'm right. So check this out. This is the X-Rite FM100 color test, and I want you to share your results. Once you watch this video, you can take this test, and then in the comments, write your score below. Let's see who has perfect color vision. Let's find out who's colorblind. Oh shit, can you still do this assignment if you're colorblind? Yes, and actually I've had some students that are colorblind that do amazing things with color because they're usually pretty good at determining differences in value. So one last thought that I want you to think about for this assignment for the color, pick a poem that really resonates with you, read through those list of poets, and do some Google searching. Don't just randomly go like, that guy's name, I'll do him, or her. Like figure out which one is actually interesting to you, and find a poem that seems to have a lot of color symbolism and mentioning in it. If you read the assignment, you can see that I use a William Carlos Williams poem, and that there are things like turquoise and shell pink that's mentioned. It even talks about perspective. So some of these poems are going to work better than others. And then when you finish any of your assignments, like the band assignment, the texture assignment, the value assignment, this color assignment, you're going to upload them to a media album. And what I want to encourage everybody to do is write comments. Because one of my best aspects of this class in Tutor Design and in any studio course is hearing from one another and giving each other feedback, like that critique that we had. Critiques can be really, really awesome. So once people start to upload their images to the media album, comment on their band logo. Wow, dude, this is really cool. I really like how you use figure ground relationships on this, or great name for a band, or hey, you made this oval shape. What if you had made 2 oval shapes in a circle? Those types of ideas. So please give people feedback and comments. I'm going to encourage that, and I'm going to include that as part of the participation for the critiques. So I'm signing off. Enjoy. Remember, take your notes and upload them to the album beneath this lecture, so that way I know you attended it, and that will count as attendance. And then use those principles to guide your project for the color. So peace out. Hope everyone's doing okay, and keep in touch. Remember, you can message me anytime. Thanks.